So we've had a bit of a look at the relationship between population and Nobel laureates in one table of data. But what we really want to do is look at the relationship between things in two different tables. So between the chocolate consumption and the Nobel Prizes. Now, in the past, when we've looked at relationships, we've tended to assume that our data is already aligned. So, for example, we'd have a list of dates, and then we'd have two pieces of data that correspond to those dates. So they're all aligned, or they have the same size and the same index, and we can zip them together, for instance, or we've paired them in a NumPy array. In this case, we want to take data from two different sources, and we're going to use two different tables. And we have to bear in mind that the indices in those tables could be different, the sizes of the tables could be different, the arrangement of corresponding items in those tables could be different. So it's really important to be able to merge the data from the tables based on the indices. Now, I'm aware that many of you will have done the databases course, and so you will have done quite a lot of this kind of thing where you're joining or merging data together, and know that there's different ways of doing that. You can do it on a union of the indices, an intersection of the indices, and so forth. So for those who are interested, there is a document that talks about the relationship, talks more about merging or concatenating objects or data frames, and it talks specifically about the relationship with SQL, okay, database style data frame joining and merging. So we're going to do an SQL-like intersection on the data, and we're going to use pandas.merge. So if we have a look at the API reference again, look at the data frame, and over here we find combining, comparing, joining, and merging. So things to do with two data frames. And the one we're going to use is this one here. Merge data frame or name series objects with a database style join. So let's have a look at that. So this method, it's an instance method of the data frame. So that means that one of the data frames is kind of the master and the other one's the slave in a sense. So it's called on one of the data frames and the other data frame is passed in. So the other data frame is passed in as this argument right. So you can think of the one that we're calling from as being the left and the one that we're passing in as being the right. There's different ways of joining, as we've just been talking about. So for example, there's an inner join, which I'm calling an intersection, or an outer join, which I'm calling a union. You can also give priority to the left or the right data frame for the indices. So the next thing is, what are the things that are matching up in the two data frames? And so we can tell it the name of a column that we want it to match up in the two data frames, or a column or an index. And if it's the same in both data frames, we can use on. If it's different in each data frame, we can use tell it what we want to join on in the left one, what we want to join on in the right one. We can tell it what index we want to use. We can ask it to sort in the process. Can be useful if our data frames use the same column names, for instance. The columns that we're not joining on, the ones we're preserving, to add a suffix so we know which one comes from which data frame. By default, it will generate a copy of the data frame, and we can also run some validation. So for example, check whether there's a one-to-one or a one-to-many, many-to-one, many-to-many relationship. So if we go back to our code, okay, so we're going to use the merge function. We're taking consumption here, which is our smaller data frame, as our primary one. We're going to merge prize nums into that. In the left data frame, which is consumption, the row, so we want to match up against the countries or the entities. In the left one it was called country, in the right one it was called entity. So they're the ones we're going to use to join on, and we're also going to validate that it's a one-to-one relationship. So neither of those tables should have more than one copy or more than one version of something that's contained in the other, an entity within the other data frame. So that provides us with a bit of a check and balance. If that fails, we know something's wrong. So let's do that. And you can see that we've got a merged table. So we've got the consumption. This was our chocolate consumption table. And this right-hand side here is from our Nobel Prizes table. So it's looking quite good, but actually something is wrong. And if we have a look at the sizes of those, okay, we can see that the Nobel Prizes one was 77 by 5. Consumption one was 14 by 2. So remember, we're doing European countries and we had 14 of those within our data that we collected. But our resulting merge table only has 12 rows. So we've lost 2 rows somewhere along the line. So remember, we're doing an intersection. That means that we're taking all the rows where the things match up. If they don't match, we haven't included them. That's what we want to do because there's many more countries or entities in our Nobel Prizes table than there is in our European chocolate consumption table. But if we want to find out what's missing, it can be useful to do a different kind of join and do a union where we include all of the keys from both tables, whether or not they match up. The columns that we're matching, we call them the keys, for those who haven't done the databases. So let's do a union and see what we find, and see if we can find out why we've lost a couple of rows. Okay, so far what it's printed there by default is not very helpful. It doesn't print the whole thing because there's so many of them, but all the ones it's printed are ones that are contained in the right-hand data frame, so the things that are contained in the list of Nobel Prizes, but they're not contained in the countries for the chocolate consumption. If we look at the head, say the first 40, so we can now see some that are in both. So some of those match up correctly as we'd expect. So Belgium and Belgium match up. Croatia and Croatia match up. Denmark, as we expect. When we get to Estonia, we find that Estonia is in our left data frame, our chocolate consumption, but it's not in the Nobel Prizes frame. So that's one of the ones that didn't match up and was excluded by our intersection. Okay, and there's no others there. But if we look at the last 40, we can see again we've got some which match up, but if we look down here we see that there's UK on the left, which doesn't match up, and United Kingdom on the right that doesn't match up. So different names have been used for the same entity in those two data frames. So we need to fix that up. So let's start by replacing, so we'll call the replace method of the data frame. We're going to replace UK with United Kingdom. We're going to do that in place. Okay, so we've now got United Kingdom here. and the other one was Estonia, remember, and Estonia had no Nobel Prizes, and for completeness we want to include that, so we can add that to a table of Nobel Prize countries only included the entity if they'd won a Nobel Prize. So the logical thing to do is to add it with 0, and so we can do that using append. So the append method will add another row to a data frame, and again we're going to add it using a dictionary. So you see we use dictionaries a lot in the pandas and data frames actually are based heavily on dictionaries. So in this case we're going to have an entity Estonia, and 0 Nobel laureates, and 0 per 10 million. And if we have a look at that one, okay, so that's appended it onto the end here. The things that we did specify were 0 Nobel laureates and 0 laureates per 10 million. The other things we didn't specify, the rank and the population, which we don't need. We could look that up and include that for completeness, but we won't be using it. And Pandas has put in not a number for those values, and because remember we covered before that numpy.not a number is of type float, and remember we also said that data frames and numpy, when they're trying to incorporate different types, they look for a type that can cover all of those things that it has to incorporate. So remember, population were integers. Because we've added not a number there, which is actually a float, it's converted that whole column to floats. And if we look at the D types, okay, we can see that population one, it was an integer, it's now been converted to a float. Now, if you want to know more about how Pandas deals with missing data, then there's again a tutorial like there was with the database joins. There's a tutorial that deals with that, which is useful to look at. Okay, so now we've merged so now we've augmented the data with the missing data. We can do our merge again and check that all of the items are there. Okay, so we've now got 14 rows again, and we've got the UK and Estonia added in there. So all of our data's there, we're ready to go, and next we're going to look at doing some basic visualization and modeling.